Hi there, my name is Christian. I'm from the SDV community and I'd like to explain you today a blueprint demonstrator. So what you see here is a virtual vehicle. So what we call it here, this is a blueprint. So if you like to have a starting point in hardware or in software and you don't know where to start for SDV working group, this is the place to go. We publish everything what you see here directly on the Eclipse SDV Blueprints project. In this case, I have implemented a motorbike blinker. If you know how motorbike blinkers are working, you press the knob down, it's blinking to the left. You press the knob up, it's blinking to the right. And additionally to that, if you press the button, it's stopping the blinking. The thing is, this sensor here or this driver input is not knowing where it's pushing the information to, because we have a very cool implementation of a vehicle abstraction layer. You see it here up there, it's the COVESA data broker. It's an Eclipse project since 3 years and it's well established, written in Rust and very performant. As well as we have an MQTT bridge, what is just using an MQTT broker interface, what is used by the Arduino devices here as easy input. I use that because I want to use an IoT protocol also to showcase it there. After I press the button down, for example, to blink, the vehicle abstraction layer is getting a signal what is standardized over COVESA VSS Vehicle Signal Specification protocol. Inside the data broker, you can subscribe for a target, so like an actuator. This actuator here is working over CAN, so we need to implement a COVESA CAN provider, what is sending CAN frames down to the device and up and receiving it. After it's receiving that it should blink, it will say I am blinking and releasing the information back. Everything of that information is directly shown in another website because this is one of the features of that blueprint. It's a fleet management backend system. So we can see the simulated data, what you have here on the left, like how fast is the truck, what at blue level it is still inside, what engine speed is currently appelling, or how much weight is inside the vehicle. Additionally to that blueprint, we extended it with the use case of the motorbike blinker. You see it here on the left. It's the graph of indication left. It's up there, it's not blinking on the right, obviously. So when I'm pressing the button to blink it right, here it comes after a small delay of the Grafana dashboard that you see it. Additionally to that, you also see when I'm braking. You see the light? It also should here have a spike that I'm braking, here up there. To show another use case, we can unlock the car. I have here some 2 RFID chips where I can just put it inside. Here, for example, this is the ID, what you see here. And when it's logging in, it's changing the ID. With this use case, we can, for example, easily implement a welcome scenario. Just imagine you're logging in, you're unlocking your car, and then the signaling on the back and in the front of your car is just blinking left, right, left, as you like. Blinking like a Christmas tree if you like to have that. Additionally to that, you can also set your seat position, what is easily then set, because every actor is completely abstracted. In parallel to that feature, all of this workload is orchestrated in a container orchestration engine, what is called Eclipse and Chaos. This is managing, for example, the Mosquito data broker, the gRPC MQTT bridge, and also the COVESA CAN provider. All those are managed here with exactly one provider. If you know Kubernetes is taking up to 600 megabyte RAM. This one is taking a few megabytes to run it. So the overhead is very, very less and it's made for automotive. All those projects are open source projects, so you can use it, you can reuse it, you can commercialize them, you can contribute on them. And this is where we have here the opportunity to have a blueprint that you see how they are working all together. Additional to the features what are inside the blocks, you see some features beside the blocks. Like that one, there is Eclipse Xeno and Eclipse U protocol as 2 protocols. One is for transport layer and the other one is for a service mesh abstraction layer. So you can also have a service mesh directly everywhere in your vehicle or outside your vehicle, for example, to the fleet management. Additionally, to the fourth stuff here, we have here 2 RTOS real-time systems running ThreadX. Eclipse ThreadX is the only safety certified open source real-time operation system in the world. And it's adopted by 1.2 billion devices, so it's really, really crazy adopted. What I have here, this first device is synchronizing on MQTT messages, and it's pushing it forward over some IP. As this is easy to use, I have used last week in one day a new library for communication. So this one is syncing up with some IP, and I'm pressing a button here, and it's directly showing in a display, and vice versa. So with open source, we accelerate AI development, and also we foster open collaboration. So you can help to get us more code, more projects, and the AI is learning how to use that very fast. So you can really, really easy get inside software-defined vehicle with AI or without AI, but with the blueprints, you have the right start to go.